Yes, that's for me. Yeah. Yeah, without water. All right, let's go, right? So if you look at kinetic theory here, right, gas laws give experimental relationship between pressure, temperature, volume for a fixed mass of gas. So we should remember Boyle's law, Charles' law, pressure law, and general gas law. All those laws are following fixed mass of gas. Right? Remember, pressure is inversely related to volume and constant temperature. So you should remember these, right? Pressure inversely related to volume, volume proportional to temperature. The letter here is whatever constant, right? And then from this, you have general gas law. General gas law is PV on T is constant. That's okay. This now is when the mass is fixed. Now we're going to alter the mass, right? And whenever you alter the mass, what will happen now? Or just here. Right now, if the mass of the gas were not fixed, PV on T will not be a constant, but instead be dependent on the number of moles, right? So instead, we will get PV on T is equal to nu something here what you should know about called moles, number of moles by a new constant called the molar gas constant. All right, so that's do my little favor. Write down that formula there. Right, the formula doesn't really look like that. It's more look like this. PV is equal to nRT and write down the value for R. Right, it's called the molar gas constant. Right, so write down the value for R. Okay, So the formula that we're going to use is PV is equal to nRT. And it's number of moles, T is temperature, P is pressure, V is volume, right? So is it up? This one is ideal gas equation. Right? And the value is 8.31. Okay, so that's the value using the R, 8.31. Right. Anybody remember, while you're writing, anybody remember how to go from number of moles to number of particles? What to do with it? How you go from moles to number of molecules? Multiply. Right. So to get so to get number of particles, let's call it uppercase N, capital N, right? It's taking the number of moles and doing what? Multiplying by Avogadro constant. Right? So number of moles is what? Number of moles is equal to N over Na. Correct? So instead of writing PV is equal to nRT, I could write this, right? PV is equal to N over Na by R by T. That's okay? And question. NR is a constant and N is a constant. To my favor now, just divide them. Divide R and NA. Come away again. R is 8.31 and divide NA. NA is what? 6.22? By 10 to the power 22, right? Divide that. Tell me what you got. 1.38 by 10 to the 23. 1.38 by 10 to the 23. So when you divide R and NA, you're going to get 1.38 by 10 to the 23. Do you think that value will ever change? No. So what we have is a new constant called Boltzmann constant. So you can write the formula like this. PV is equal to NKT. So what's the difference between them? One is used when you have moles, one is used when you have part number particles. Okay? So you have to know which formula to use, and it's based on which N you have. Uppercase or lowercase N. Right? 10 to the minus 10 to the 10 to the minus 23. Sorry. Yeah. I did somebody wrong. What? I did number 23. Huh? I mean. I'll fix it. Fix this picture. That's the name of the video. No, he did. I think he was online. Right, so quick little thing, only an ideal gas obeys these laws. No such gas exists, but nevertheless, these laws provide a fairly accurate description of the way gases behave when they are at low temperatures and temperatures which are well above those which are liquefied. As said earlier, the internal energy, we're going to talk about this, right? what's the internal energy of a gas? The sum of its kinetic and potential, right? But in a ideal gas, is there any potential energy? No, it's purely kinetic. Right? It's purely kinetic. All right. So we're gonna work on this in a little while. Right? Before we do that, anybody remember how to explain like why it is if pressure going up? Why it is if pressure will go up if temperature increase? Right, so the particles will gain more energy, they will move faster, collide more, right? And because of the greater number of collisions, you have the greater pressure. Okay, so I want you to remember that order, right? Increase in energy, move faster, collide more, increase in pressure, right? And we have to look at the law of thermodynamics, which kind of helps us explain that, right? Before we move on, just do our favor. What's the relationship between kinetic energy and temperature again? How are they related in a gas? Proportional, right? So make a note of that. Kinetic energy is proportional to temperature. The reason for that is that we have to create a relationship in a little while, a little formula, right? To show that. Everybody with me so far? Make sure you follow everything. I got to be a nice, easy topic. Right? So if I ask for a microscopic explanation, you talk about kinetic theory. Right? Talk about how the particles move. When they say macro, that's where you deal with the formulas and variables and things, right? Which we'll do in a little while. Two quick questions. Find the volume and find number of moles. What's the SI unit for temperature again? Kelvin. Must be in Kelvin, right? Do my favor, use the right formula and find each one. Yeah. Okay. Which one are you using? 273.15. Yeah, 0.15 all the time. Yeah, don't forget 0.1. 0.16 as well. What we score that? What's the next name for it? 270.16. Triple point of water. Right? Triple point. Do that pass.
What the first? This is yeah, you're on it. Six. Yeah, I will buy it cheap. Wait, I'm doing. You serious? Yeah. Oh shit. Done. Wait, shit. Halfway back. Yeah. I don't know. That kid is saying. Well, it's a. Who's so? What's it? It's my fault. It's saying no. C'est la pêche, c'est la pêche,
Alright. Wanna get you?
She's going to
Wait, the cable. I want to. Yeah, I find it right now though. I'll two of it. Actually, well, get this way. Oh yeah, the model something or no, no, wait, it was something similar. Buy one, get one. Right. Hmm? Buy up. I always say so.
Yes.
What I get you? So they give you volume, they give you pressure. We don't want this temperature. We have to add a 273.15, right? And they want us to get a number of moles. So we're using PV as nRT, right? And N is equal to PV all over R all over RT. Right? My pressure value is 2.4 by 10 to the 6. Volume is 5.5. R is 8.31. And temperature, what is that? 298?
Yeah, 298.
Alright. How much you get for number of moles?
5, 6, 7,
How much?
5, 2, 3, 7.16.
5237.6.
0.6.
Right?
I don't think I'm correct at all.
8.31 is R.
That was so.
Yeah.
That means. But I'm not looking at that. So
It's the second question. The chemistry students.
Well, yeah. Yeah, but again, the same thing. Just like that. And it's actually about particles and moles and all kind of thing. But again, that's the same thing.
And who's the
Right. So in the question say number of moles using small elements. Lowercase m. And if they say anything with particles, then you use any only capital M. So you do one. You have page number 2?
It's not that I just thought.
Part one, yeah, using capital M. Right, so online, just message answer now.
Who's the answer? So check on so see
You done, send them answers now.
生报你干嘛？就每个不一样嘛，有听到有一点做是啊，知道你。做一点什么？
You done, you there?
好，这个是可是。所以那个大学毕业了，这个先介绍会告诉我。
Nah, you hit that. Probably you said you know something, so.
知道，是我没有帮助。
The what?
Here's what you're doing. Let's get shot. What you're right. That's why you can't pay.
Keep that, yeah, no, no.
Now we need done.
All I get you, number of moles and temperature, pressure, they want us to find gold, right? So we know that V is nRT all over P.
So I'm gonna put you.
So whereby
It was so yeah, we can't put you because I'm again. So that's sensitive. And there listen.
I can't.
Everybody will say we saw. So you said you keep.
Might be lucky, might get into someone
So
today.
can't see how come in.
I wish I can get it down to it.
Now we go for this go right. Go right now on stadium.
Pressure is 4 by 5 by 10 to the 6, N is 0.5, R is 8.31, and T is? Oh man, I 381? 318. Oh, 318.1. Right, plug it in, tell me what you get for V.
0.5 by 10 to 4, okay.
2.93
by 10 to 4.
negative.
4.
Right.
Yes.
I do for the yes.
Yeah.
That's it.
So we come.
Oh, no.
I see it as a
Me?
it's a motion. That's really
Most of my see me use it.
it's a pose.
I have a group name freaked out in my car, actually. As it most of my videos.
See it very true.
I know, but we change my wife.
What's the fine? It's like fine.
No, not farm. It's not go to big, like a big one, I don't. I like
Good to be with someone.
some others have like.
And it's how good.
Yeah, it's not a good thing. But that doesn't do capitalize on thing, being able to have one of. But if their main thing is not true. Right? Assumptions of kinetic theory, we know this already, right? Right? These assumptions are the molecules are identical, collisions between them are perfectly elastic. Remember that ideal assumptions, huh? Right? The molecules exert no forces on each other except during impact, which are assumed to be negligible during anyway. And the effect of gravity is ignored. Between collisions, the molecules move in straight lines. The motion is random. Right? There is sufficiently large number of molecules for statistics to be meaningfully applied. So try to remember that the questions will always ask you say 2 laws, 3 laws. You have to remember a few of them, right? Right? And so on, law of mechanics apply. Nice. So here's what we need to look at now. I'm going to do the proof on the board, it's in your notes. You don't have to write out, right? But I want to do it on the board so you can see every step. Here's what we have to look at now. What we have to look at now is how do we find the pressure exerted by particles inside a container? So if I have a cube, right, and inside the cube I have particles moving, we need to figure out what contributes to the pressure. We know for sure collisions, right? So I'm going to show you how the proof is going to work. We're going to consider one of the particles. Remember, you have n molecules in there, right? We're going to consider one of them. And for that particle, remember that particle can move in any direction, x, y, or z. We're going to consider it moving in one direction. Then we're going to try to observe how the pressure is created, right? You remember the formula of pressure? Pressure is what?
Force.
Force on area. So think about this one molecule here. When this one molecule hits the wall, the exerting a what? Force. It has an area. So there's a force acting per unit area. So imagine you have one molecule doing that, right? Imagine you have n molecules doing that in 3 different directions. You're gonna see what the pressure will look like. Everything I'm going to give you now in there. But I want you to understand what I'm going to do, right? I'm going to consider one particle moving in one direction. And all the particles moving in one direction. And then I'm going to consider the all 3 directions. Of course, I will simplify it, right? But remember, they allow me to use the statistics. So instead of finding all the, I'm going to find the average, right? Yeah, so I'm going to do some averages, right? So what you will recognize here is, I wanted to show you something here, right? Hold on, eh?
X bar.
Right.
X bar. X bar.
We're going to come all the way down and prove this formula here, right? That c squared, because those are lines around it, means mean, right? It's the mean of the speed squared. Okay?
So the mean now?
Mean speed. It have mean speed squared. Mean square speed, right? So you're finding the mean or the square of the speeds, right? And then they have root mean square, RMS, right? Which is like an overall average. So we're going to try to prove this formula here. All right. So just take a 2 minutes and just run through the proof in your notes so you'll know what I'm doing on the board. Don't write anything. Eh? All I want you to do is just to take a quick little read through. I don't want you to get lost when I'm doing the proof. Take a little 10 minutes.
So when you say you're gonna drop statistics, right? You're gonna drop anything with x and x minus x bar, and then x minus x bar squared, or like no, this.
And this one. Right.
I said that I can go that thing. So I do with you now. Yes, you know what's that. What this is Alan. Will you do that to the
Right. Should have been done. Ready? All ready? Yeah. Watch here, right? So again, everything in a cube. Everything happening in a cube. Focus on one particle in there. Focus on one particle in there. That particle moving with a speed of Vx. X just means the X direction. The mass is M. Right? It have 2 faces that we're going to look at, face A and face B. It's a cube, so all the size is L. Everybody okay with that? Before we jump into it, I want you to remember a few things. Force. How you find force? Right, or? Right, or change in momentum all over time. That's okay? Change in momentum on time. And then we have pressure. Pressure is equal to force over area. Right? Last thing, and I want you to remember how you find mean. So if I were to find the mean of C, mean is what? You sum up all these C's and divide by it. Right? Just remember that, right? All right. So first step is to find change in momentum. So if it going this way, right, and it hits the wall, assuming it's elastic, the velocity will be in the opposite direction, will be same velocity, right? That's different directions. So how do we find change in momentum? Need to pay attention now. Right? So the change in momentum will be the final momentum minus the initial momentum. Right? The reason I have a negative sign here is because it's opposite direction. Same speeds, right? So I'll end up with, this becomes a plus, I'll end up with 2 mvx. That's okay? Yeah, the mass staying the same. We are assuming everything elastic, so nothing changing. Right? You sleeping on yourself again, or are you waking? Right? So your change in momentum is 2 mvx. All right? So it means that we can find the force exerted by this one particle, which is change in momentum, divided by time. That's okay? Are you okay with that? How we could calculate speed, right? What we could look at is we assume the particle leaves here, and we could take a look at time between collisions. So we could look at the time, between collisions, right? Remember that velocity is distance on time. Time is distance over velocity. Question. Was the distance covered from here to here and back to here? Right? That's called distance time between collisions. Because remember, when it leaves here, collides here, and then the next time it collides is here. So time between collisions is what? Is distance traveled, which is 2L, and the velocity it's moving with is Vx. Are you okay there? Now, let's put that in there. So we will get the force of one particle as 2 mvx all over 2L Vx. Flip up the Vx, 2's will cancel. You'll end up with m Vx squared all on L. Right? That's the force exerted by one particle. Huh? No, that's not a good. Right? So that's the force exerted by one particle. Now, pressure is what? Force over area. So the force is mvx squared on L. Let's find area. What's the area of one of these sides? L by L, right? So I can divide by L squared. It will flip up, and you will get mvx squared all over L cubed. Where's that? What's L cubed over cube? What L cubed over cube? What L cubed? Volume, right? So technically, what do I have here? I have P is equal to mvx squared. That's okay? So I have the pressure exerted by one particle. Everybody okay with that? Now I'm going to change it to n particles. All right? So I could say PV, you gotta remember the formula we're trying to prove. PV is equal to what? MV. No, but I forget. We'll do this now, right? But so far we have PV is equal to mx squared, right? But that's for one particle. So how do I start to include 4 n particles? Nah, not yet. That's coming. But m particles, they all have the same mass, right? Right? So, and it will be something like this. It will be the speed of the first particle squared, speed of the second particle squared, all the way until we reach speed of the nth particle squared. That's okay? What am I going to do with this? Right. So now to bring in mean. Right? How do we find so if I want to break this up, how do we find mean again? Sum of all of this and divide by n. Okay with that? So if I multiply n by the mean, I'll get this. Adam is going. Right? If you multiply n by the mean, I'll get this, right? So I'll get PV is equal to mn by speed square, right? Okay with that? So n by speed squared is the total sum, right? See that here. N by the average is total sum. Okay? So far? Right. So remember, this is only in the x direction. What I'll do now? So I have all n particles in the x direction. How are we going to get the other directions? Well, here's what I'm going to do. Remember, we can have the x direction, y direction, and z direction, right? Right? We can have all three. To simplify things, here's what we're going to do. You all remember that the resultant of these two is like Pythagoras theorem. There is a resultant for all three as well. So we're going to say that the resultant for all three is Vx squared plus Vy squared plus Vz squared. Right? Same concept that you apply to 2 dimension, you apply to 3 dimension. And to simplify this here, Adam, before you fall asleep, we're going to make them equal. Making them equal. All three equal. So it means that mean square will be 3Vx squared. Everybody okay with that? So what is Vx squared? Vx squared will be 1/3 c squared. So I'm going to remove this, and now I have PV is equal to mn 1/3 c squared. Right? And more formally, it looks like this.
So that's flagging.
Huh?
That's only flagging.
That's only here. So we just simplify all the conditions, but of course it'll get more complex than that. It don't just move, it can move all in between here.
So
Right, same. So we had to go and look at the pyramid dimensions and move on. No. But your level, that's where it stops. Nah, your level, that's a cube.
So this is one part. I mean, I keep going.
No, this is all the particles in 3 directions.
The left side, it's
The left side is one particle, one direction. Here, n particles, one direction. Here, n particles, all the direction. This is the notes already. You don't want to write this down. Write down everything in between. Okay? All I want you to do is write this down. Right? We'll write this one down. Just the last one. Just the last one down. Hey, this is very distracting. I don't even want to write it down. Where write it go?
right.
Yeah. We just have one more thing and we could jump with some questions. Huh? The normal option. Right? From now on in time to this week, from before. I want to go to the 4, but I feel like I survive in physics after that pure. Kevin makes the lap out school. I might just want to eat. Oh, my to organize back up there, right? I'll look at coffee station.
Yeah,
I'll put it back. I had one in about so like it just pets or something like a mashup.
Oh, right.
Huh?
You have those are
Right? So now that we reach here, Now that we reach here, there's a couple things that we could do as well. Huh? You gotta remember what is what is like density, mass and volume. So what would happen if I take the mass, total mass, and divide it by V? Formula becomes 1/3 density. Right? So you gotta be aware of that, right? So let's make a note of that. Density is equal to mass and volume. Right? You'll recognize that the theory behind it's not hard, but it's about 6 formula you have to learn. Right. Now for the last part. We need to show this, Adam. Kinetic energy is proportional to the temperature. I help you up to reach up to here. I want you to tell me how we're going to bring in kinetic energy and temperature. Kinetic energy is a half mv squared, right?
Yeah, right.
So based on what I showed you earlier today, I want you to figure out how do we take this and turn it into something with this relationship. Okay, now I start thinking like this, right? You all seen temperature here? So I had to figure out how to bring in temperature. A half mv squared, well, we can do that because we have the 1/3 of the mv squared. So we could turn that into a half somehow. But what I'm not seeing is how we bring in T. Nathan, between Nathan and I.
Yeah, nothing is it. It's
It could be like something like MC del that theta, so you can kind of be some.
MC delta.
I was just specific.
Max I ever need. The long one, the only body foolproof like once or twice so far. But what I'm showing you now, that's very good. I want to feel back.
See, I need to check out that.
Yeah, you see? General gas, so general, you want to say?
No,
Ideal gas equation. Right? You want to use the ideal gas equation, but which one? You have two, PV is nRT and PV is NKT. You want what? NKT. So if we use PV is equal to NKT, can I remove this? PV is what? Yeah. So now I could say, well, here's what PV is also equal to 1/3 NM mean square. Right? You all remember what this means, right? This means the mean square. You square all the speeds and then you find the mean. So this means the mean of the speed squared. Right? So you call it what? Mean square speed. Okay? When they say root mean square, they mean the square root of the mean square. All right?
Yeah.
Right? All these two will equal, right? You will equate these two. NKT is equal to 1/3 NMC. N will cancel. What do you do now? I will get a half, right? How do I turn a third into a half? Multiply by 6. I turn into a half. Multiply how much? You sure?
Yeah.
No.
Should it's not half, sir.
No, that is. Huh? You close it. Multiply by what?
Century.
Right, 3 on 2. 3 on 2. So you'll get 3 on 2 KE. 3 to cancel, you'll get half MC squared. This is kinetic energy. Right? So we just prove it.
So, you know, right?
Yeah, also you know. That's okay? Right? So do me a favor. It's supposed to have 1, 2, 3, 4, 5. Supposed to be 6 relationships.
So that no.
Yeah, write the handle, but I want you to write these 6 formulas separate from another corner. Right? We're gonna try to apply it now.
So, going to one line, six of the.
Well, you have this, 2, 3, 4. Right, PV is equal to nRT. 1, 2, 3, 4, 5. That's all. One missing.
Sorry, teacher, you not mix it.
Oh, when you substitute in here, right? So we can leave it at least 5 for now. Right? When you carry across volume and you substitute. All right, so that's the relationship there with the ideal gas equation or the conclusions of it. Okay, we write them all 5 and let's see if we can apply them now to third one. Right, so as I said, to complete this module, all we have to do again is thermodynamics, right? Then we do a review and hit the trickiest one.
You suck.
You don't need to start right?
Well, you don't have
So I have classes.
you don't have
Then I have I rotated now from 5 and 2 to.
It's which one of them?
It's easier to avoid with numbers.
Selama não sei do like where is that class.
Anyone know?
That's how it used to be, you know, and everybody wanted it on start.
That was that one.
So I'll try and start. Let's start now. We have 2 questions.
Wow.
Right, look at the way divide mean square, right? Same thing, right? Divide the little arrows around the C. Might mean the same thing, right? Mean square. Right, follow clear part A and B. What they asking for in part B? Part A just give all the meanings, right? What they asking for in part B is yeah? Part B.
You are gonna expression.
What's the talking about? What's the formula? Right, so they're basically asking for this right here. Right, they're asking for the same proof on the right hand side there. Right? Shut it down fast and let's go to the calculation. Right, they're only asking for this, huh? He just writes in from here to here. That's it. That's part B. They don't want all of this. They just want what's on this side here. Okay, that pass and let's go to part C. Only 3 marks for that. That's this alone has 1, 2, 3 lines. Okay, that part C. Part C quick. Right, look at how quickly it's done. Are you done? You have volume, you have temperature, and you have pressure. Find number of moles and then number of hydrogen atoms.
是那个那样子，是
or you have later.
让我这个这次是我
这里是不是表示这个
Common N is moles. Capital N is number of particles.
做完一个准备跟上的，
We have other violence again, green side practice it.
这个个吧，我看。
We use this next after this is we. Anything else you got?
是啊，我会。
What you got? Part one. You get all you done?
Yeah.
Are they confused?
Yeah.
Yeah? Yeah?
Yes.
Right, so look at what we have. We have volume, we have pressure, we have temperature, and they want us to find what? N, right? Which formula have PVT and small n in it?
NRT.
Right, PV is equal to NRT. That's all.
I got 0.3.
So PV on RT,
so give us up
8.31, and T there, T is temperature.
6.3. 3.8.
0.38.
不是是一个球。Juice put that.
No, not 8.31, I mean like when you work it out.
Number
Yeah, number of moles here.
yeah,
0.38.
so
Anybody else get up? Adam, how much you got?
8.2.
Adam,
0.3.
That's not good.
Adam, there's a crew you have there?
and so
No, yeah, I got it. Who you up? Crew. You want to one log in now. And I will right on the screen.
So it's international.
I can.
What it shows 0.38?
so why is it okay so
What you got?
I don't need to come
It's working back fast, not more you got.
Sample, the background.
Yeah, put Nick again some more you got. Anybody online or something different? Pressure is 10 to the 5.
6 by 10
6 by 10 to the 5.
So you have it.
Identify.
You have it long.
that's
Yeah, that is the pressure of 10.
I can do minus. Okay, yeah. So I can 3 minus 3 of right?
Yeah, 3.5 by 10 to the minus.
Correct. Yes, again, 0.63. 0.631. So
Okay, 0.631, yeah. 20 rounds.
I'm waiting. Okay, 3. So I'll back.
So your number of moles is equal to 0.631. How you'll get the number of hydrogen atoms? Using next formula, right?
yeah.
PV is equal to NKT. I say again. Right, when again, write in this screen from up.
It could be long.
Yeah.
Okay, no, next.
Right again, I'm saying.
Around the
I still take it off now. Put it in my touch. Okay. I know. Take it off. Just press on.
So the issue.
Right. Find K from a place. Same concept, right? PV is equal to, sorry, I meant find N. PV is equal to PV over KT. You'll follow why we use that formula, right? Based on what you want moles, right? And that's where I'll work it out. Right? While you're working, is there next way I could have done that? If I have moles, I just get number of atoms. Just multiply by Avogadro's, right? So instead of doing the whole thing, they could just multiply by Avogadro. Who's the guys? Same thing. How much you get for your N? What you get for N? 3.8 by 10 to the 22. Right? You all might like this part, but the question said atoms. So what to do?
Nah, so this game too much like chemistry.
Yeah. Right? Remember hydrogen exists as what? H2. So to get a number of atoms, what you do? Multiply by 2. Right? Remember it's H2. If they said number of molecules, then you can stop.
Still, but I don't even know the question.
Yeah, the question still there. Hydrogen atoms.
Yeah, but we do physics.
Yeah, we do
what
atoms.
what does somebody taught? No, but chemistry taught. Exactly.
Well, all I correct this was no hydrogen. You must know that.
So I never learned physics in form five. So we could give it though.
Right, but yeah, I know them things. H2 and things all from chemistry, chemistry and things must know all the gas particles and how they bond and
So like you're like expect if you use an example, right? And expect the big question.
What's the iron being?
you know now, right? They say hydrogen gas, right? Yeah, look out for that. And last part, I'm done. The last part is find the average kinetic energy. Find the average kinetic energy, and be done. Wait, who's Noah? Oh, that's it. I want to do it. I don't have that name on it. Nathan, do something now. Do the last part. All right, tell me the formula, Nathan. How do you find kinetic energy? Average.
It can be three. Three over two.
All right. K is how much?
Yes,
K is what? No. What's his numbers? K is what?
Yes, 400.
Temperature is 400.
I don't want to give yeah.
And no, don't give him K is what? Look back in your notes in there. K is what?
So that's the thing you doing notes. How about
Then I'll give the right hand. I'll give right somewhere right. You have that. K is 1.38 by 10 to the minus 20. So we add up the final part since the right to go.
Yeah. It's not.
Oh yeah, last part.
Second
Last how much you got?
So why is that sorry answer?
Sorry to turn you off. What you got? I think you just multiply the thing from another way.
So we do tomorrow. 8.28 minus 3.
joules, right? Now we done. Alright, so today we look